Hey there, Vince here, and welcome to a Sleuthing Circuit Rewind.
But what happens if I get lag out there? I'm dead!
Before getting into the content today, there are 2 points I'd like to go over. First, apologies for all the flashing screens. This will be a theme throughout this entire video. For those of you that are photosensitive and don't wish to watch this video and maybe only listen to it or not watch it at all, I completely understand. There will be flashing bars in almost every single scene in this video. The bars will always be off to the side as they are now, rather than me doing actual video capture, so they shouldn't be all that large on the screen. Secondly, if I look like a hot mess today, let me tell you I feel it more than I look it. The weather has been hot lately, and I don't have AC. The windows are open, it is noisy outside, so if you hear a lot of noise, sorry, it's the best that I can do with the situation that I have today. So let's get into the content. What do I actually have sitting right here? This is a Time Sleuth. This is a very basic device for measuring display signal latency. As you can see, there's not a whole lot going on with it. We have USB power, HDMI video output, what I'm assuming is a programming interface that I don't use. There is a mode dial with 5 modes on it, an LED indicator, and then on the back, not an LED, but actually a photo sensor. So the way this works is we take the photo sensor on the back and line it up with one of the white bars on the screen that's being displayed from the HDMI signal that this is producing. Every time the white bar disappears, the LED will pop up, blinking on and off with the same frequency, so that way we know it's actually working. On the screen, we can see what our display latency is. This is how long it takes from the HDMI signal generated to the time that white bar appears on the screen. In this particular case, we're looking at just over 10 milliseconds. What's important to note is that the screen draws top to bottom. Because of this, you will have lower latency at the top compared to the bottom. This is very important when you're comparing one device to another because depending on where you hold the Time Sleuth, that number will change. Even within the section of just this bar, if I move it up ever so slightly, we are now below 10 milliseconds at 9.8, but if I ever so slightly bring it back down, we're now down at 10.3 milliseconds. And that's all within a fraction of an inch, within just these few lines on the screen here. And then for the top bar up here, to see where the signal starts, I have to hold the Time Sleuth upside down because of where the photo sensor is, to get it all the way up in the corner to barely be able to register that signal. And you can see what we are a little under 3 milliseconds at 2.86 milliseconds. And if we go all the way to the bottom of the screen, we are at about 16.6 milliseconds. This number here is very important to note. If you're running at 60 Hertz, 1000 divided by 60 is 16.6, so 16.6 milliseconds. There are 5 modes on this particular device. Right now you can see we are sending a 1080p signal at 60 Hertz. If I flip the dial down, the signal switches to 720p at 60 Hertz. One more time. We are now sending 480p at 60 Hertz. The next 2 dials don't actually work with this particular screen. They are 480i, so interlaced rather than progressive, and then a 240p mode. One note about the Time Sleuth only having 60 Hertz signaling, I wish there was a secondary dial to adjust the frequency separate from the resolution. Right now this only does 60 Hertz, no other refresh rates. I wish this had settings for 50 Hertz for PAL testing, or 120 Hertz or higher for high refresh rate monitor testing. So this device is not perfect, but this gives a good example of how different equipment adds different types of latency to the signaling. Now let's go check the complex video chain that I've built on my entertainment center. So the Time Sleuth is plugged into my 16-port HDMI switch. This allows 16 HDMI devices. I can change between them at any point, and it has a single output. So only one of them gets to work at a time. Port number 2 is where the Time Sleuth is plugged in, so it's feeding that video out now. That runs through my HDMI matrix. So this is 4 inputs, 4 outputs. Any output can show any input. So if I want all 4 outputs showing one input, that'll work. If I want all 4 outputs showing 4 different inputs, it can do that too. From the HDMI matrix, I have an HDMI to VGA converter. The HDMI to VGA converter is going into my VGA matrix. This has 8 inputs and 4 outputs on it. And just like with the other matrix, any output can show any input, whether it's the same or different. And from there, I have this being outputted to a CRT monitor. So let's see what that does for latency. Hopefully this is capturing well, because CRTs are sometimes hard to capture due to how quickly they actually draw their screens. So I'm going to take the Time Sleuth, place it up to the corner of the screen here, get it right around where it should be. As you can see, getting it at just the beginning of the video feed, we are getting less than 0.1 millisecond of latency. Basically real-time signaling from the HDMI through all of those converters and matrices and switchers that I just mentioned to the CRT. They're adding literally 0 lag to the signal. I wanted to show that first because now that I'm going to start playing with other devices, I don't want any of the comments saying, oh, that piece in your chain is adding the latency. It's not the thing you're currently testing. Right now we know that both of my matrices and my switch and the HDMI to VGA converter do not add latency. They take the signal and immediately convert it and shove it out the other end. Let's try something funner. I have the video signal running from the HDMI switch to the matrix, from the matrix out to VGA, from VGA into the OSSE. The OSSE outputs HDMI back to the matrix. The matrix is using a different VGA link down to the VGA matrix, and then it's outputting to this screen. This way we can see what kind of latency the OSSE adds to the signal. As you can see here, the OSSE menu is currently visible, showing that this signal is indeed running through the OSSE. Right now it is also doing line doubling. If I bring up my menu on the monitor, I can go into display mode, and you can see that we're running at 1280 by 1024, even though the initial signal is only set at 480p. And these numbers here are approximations. They're not exact because it's just the way the monitor's processing works. So let's close out of this menu, close out of the OSSE menu, and see what kind of latency we get on this signal. Right now it looks like 0.34, 0.35 milliseconds of latency, so a third of 1 millisecond. And remember, 16 milliseconds is 1 frame. So this is still effectively no input lag that any human would ever notice. Because again, if we bring it down here to the middle of the screen, that's already at 7 milliseconds, and the bottom of the screen is going to be at 14 milliseconds. So this just goes to show that the OSSE does a really good job of converting a signal when line doubling and outputting. For this next test, I'm going to try this HDMI to component video adapter and looping it back through the OSSE again. And we can see that our latency is virtually identical, riding in that 0.35 millisecond range. That adapter isn't really adding latency at all either. This is also running with the same line doubling that we had before. I can go into settings, output settings, and switch this over to pass-through mode instead. Now when I check my monitor, you can see 640 by 480 matching the 480p that the signal's generating. And we're getting essentially the same 0.35 millisecond latency, showing that line doubling does not add any latency at all to the signal. And now the part I've been most curious about, what happens when we do the same thing with the RetroTink 5X Pro? As you can see here, I am running experimental firmware 3.62, which is recent as of last week. I'm using the same component video adapter, so HDMI to component. So let's go to the lag testing screen and see what we get here. Interestingly, we are getting about half a frame of lag at 8.6 milliseconds. But there's a reason for that. Let's go into the menus again. Let's look at HDMI. It's currently set to triple buffer. So let's change this. Now that we're in frame lock mode, you can see that we are under 2 milliseconds. Setting it to gen lock mode, we've actually increased up to 13 milliseconds. So let's stick with frame lock, and let's also try locking to 60 Hertz. In this particular case, there's no real difference. Through these settings, we can now see what actually affects latency on the RetroTink device. For instance, let's try switching to a 720p output, and now we're sitting at a little over 2 milliseconds of latency. So there we have the RetroTink 5X doing a really good job as well, but not quite as fast as the OSSE when converting an analog signal over to digital. Now let's test the 5X Pro at different resolutions. So right now we're sending it a 480p signal. However, this device is supposed to be optimized for 240p input. And at 240p, it looks like we're getting about 1.69 milliseconds. Switching this over now. Let's try 480i, another common resolution for retro video games. And this looks like we're about 1.6 milliseconds as well. Okay, take two of this part because apparently I bumped the microphone and turned it off while I shot this last time. So now what I've done with the video chain is I've added a VGA to SCART downscaler. So this will take a high resolution VGA signal and downscale it for a SCART signal. And I have that running through the RetroTink 5X Pro to convert it back to HDMI. And then it's being, once again, converted from HDMI back to the VGA signal that we see on the screen here. What's really important to note, first off, is how much dimmer this signal actually is compared to what it should be. The voltage levels coming out of the SCART adapter seem to be much lower than they should be. For instance, if I bring up the RetroTink menu, you can clearly see the brightness of the RetroTink menu compared to what is white, or max brightness, coming off of the SCART signal there. So now let's measure some of this latency on this. If you notice this value here, all over the place, it's continuously counting down. So it turns out the VGA to SCART adapter uses a frame buffer, and it has its own clock source generator. This means that it's constantly putting out its own 60 Hz signal versus the 60 Hz signal coming in from the Time Sleuth, but both of them are in slightly different frequencies, so that one of them may be slightly above 60, one may be slightly below 60, and because of that, the two of them don't quite synchronize up, and it simply shoves out a frame whenever it wants to. And we can see this go here as that value is constantly counting down, because that's basically the time difference between when one clock is wanting to send a signal and when the other clock wants to send the signal. It's very inconsistent over time. Different adapters work in very different ways. As you can see here, and it can't even keep synchronization, 480i signal, so interlaced, just does not want to work with this downscaler. If I set it to 240p, it just doesn't know what to do at all. The final device I want to test today is my main gaming television. This is an LG 65-inch C9 OLED panel, and these are known for having really good low latency. So let's see what we get. That doesn't look low latency at all. We're getting in the mid-90s right now, like 95, 96 milliseconds for latency. So what's going on here? Let's go into our settings on the TV, and let's change our picture mode. As we're going across, we can see that the colors slightly change, and also in cinema mode, the pixels are now kind of smeared and blurred together rather than being crispy. Let's keep going. Sports looks nice and crispy. However, when we switched to game mode, the screen went black for a second, then came back. Now let's test what our latency is at. It starts around 25, 26 milliseconds, and all of a sudden it drops down drastically to right around 9 milliseconds. So this is what's known as a low latency or game mode. Different TVs have different marketing terms for this. On my TV, I specifically set it to game mode. It will also put up a notice sometimes saying, I think, instant response mode. There's a few different marketing terms for it, and even within itself, it can't keep it consistent, whatever, it doesn't matter. I'm not going to test the different resolutions because I can tell you that they all behave exactly the same on this screen. So make sure that you set your TVs to low latency mode if you want low latency gaming such as this. You know what? All this blinking is starting to get a little annoying, isn't it? So let's get this turned off. So what does this little device mean for you as a gamer? If you're a casual gamer or playing RPGs or whatever, not a whole hell of a lot. It doesn't really matter. But if you're into esports or if you're into speedrunning, it's a competitive scene just like any other competitive sport. If you're out there playing football or baseball or whatever, you want to make sure you have the best equipment possible if you're going for that competitive advantage. The same thing goes for this. This is a tool for measuring part of your tools for competitive gaming. If you're a speedrunner and sometimes you're making that frame perfect jump and other times you're not, maybe it's like what I was showing with the VGA to SCART adapter. There may be some device in your chain or possibly your display itself that is adding just that little bit of latency that's variable over time, making your input latency just a little bit different each time you press the button. With a device like this, you can start to measure all those little variables within your chain to get you down to as little latency as possible. How do I feel about this device itself? Like I said at the beginning, I wish it had other refresh rate modes. My LG C9 that I just tested was at 60 Hertz, but that's a 120 Hertz panel. It'd be really nice to test that. It is also a variable refresh rate panel, and I believe it can go all the way down to about 24 frames a second for cinematic type content. And it would be nice to see this be able to do something like that, because as we've seen, even though we're living in 2023, there are still games being produced today that run at a paltry 20 frames a second. If you're not a competitive gamer though, none of this matters. If you enjoy playing video games, continue to enjoy playing video games. Please don't worry about any of this nonsense. That's all it really is. I didn't go through and benchmark every single display that I own like I originally wanted to for this video, because at the end of the day, that's just nerds comparing numbers back and forth, and that doesn't really tell the whole story. The whole story is, do you have fun doing what you do? If you do, keep doing it. If you're competitive, your setup is going to be different than mine, so me benchmarking all of my displays and all of my video chains really doesn't matter. The whole point of this is just to show a couple quick examples, and if there's others you'd like to see, I'd be more than willing to explore them. For me, what I find fun is just playing with toys. Just about every video I make is me playing with a different toy of some kind. And today, that toy happens to be the Time Sleuth. And I'm going to continue to play with it. If there are other ways you want to see me play with this, other devices to add to the AV chain, other types of displays to test it with, let me know down in the comments and I'll see what I can accommodate. I'll also be taking this with me to various live events that I go to. I'll probably have it at the PAX BYOC later this year, as well as PDX Land. So if you're at either of those events, send me a message and I'll let you know how to get a hold of me at the event, and we can test your equipment there. Like if you want your monitor tested, I'll do that for you and show you the results. I'll let you test it yourself. You can borrow the device. So in the end, all that matters, have fun. And I'm going to keep playing with my toys and find new, weird, intriguing, interesting things to do with them. So until then, see you next time.